In this video on systems of linear equations, we're going to discuss how we solve the systems algebraically. There's two main methods for algebraically solving a system, and one of those is by substitution and the other is by elimination. With substitution, you choose one equation in the system and solve for one of the variables, and you'll get an expression. You'll substitute that expression into all the other equations for that variable. Now what you will have is one less variable and one less equation in your system. You'll continue this process of solving for a variable and substituting it in to the remaining equations until there's only one variable to solve for. And you will then have a value for that one variable, and you'll start substituting now values into the earlier equations until you have all variables solved for. With elimination, you look at your system and you decide which one variable you wish to eliminate. Using multiplication and division, you're going to create pairs of equations with opposite coefficients of the chosen variable, meaning they will be additive inverses. You're going to add equation pairs to eliminate the chosen variable. When you do that, you'll end up very similar to what you had up here, one less variable and one less equation. And you'll continue this process of elimination until there's just one equation with one variable, very much like in substitution. And then you start substituting in the values for the known variables until you have all variables solved for. It's easy if we just see a couple of examples. So, in a two-variable system, let's start by looking at substitution. So here's a system. You have a couple of choices here. You could use equation 1 and solve for y, and then substitute that into equation 2. Or you could look at equation 2, and you can see that it's already solved for y, and you could substitute that expression in to equation 1. And so I'm going to do that one, and I substituted in the value 2 plus, or excuse me, the expression 2 plus 0.25x for the y. Collecting like terms and now dividing by 0.05. Remember, that's multiplying by the reciprocal, so it's going to be multiplying by 20 on both sides. And I get that x equals 40. Now you take that value, x equals 40, and you substitute into the other equation 2. Since we already used equation 1 for the substitution, you need to substitute that value into equation 2, a different equation. And collect and simplify, and we get the y equals 12. And we check it, that does it work in equation 1, that's important, and it does. And so therefore the answer to this system is the ordered pair 40, 12. Now the other method by elimination is I have two equations here, and we decide which variable to eliminate. And so we're going to eliminate the y. So what I'm doing is I'm taking equation 1 and I'm going to add it to negative 4 times equation 2, because when I multiply equation 2 times negative 4, I end up with opposites. I have a positive 4y and a negative 4y. And collecting like terms with those two equations, solving for x, I get x equals 3. Now I'm going to use equation 2. You could use either one of the equations, equation 1 or equation 2. Substitute in that value for x and solve, you get y equals 0. Now I have to check it, and since I used equation 2, since here I used equation 2, I need to check to make sure that it works in equation 1, that 3 and 0 give me a true statement, so I need to plug it into this equation. And it does, so the answer to the system is the ordered pair 3, 0. Now when we have systems with more than two variables, 3 or more variables, we still have substitution and elimination. Substitution works sometimes when given a very specific type of system. You'll notice in this system, one of the equations is b equals negative 1. So we can use that right away and substitute that in to equations 1 and then solve for what we've got, or simplify that equation. And then substitute that value into equation 2, and once again simplify that equation, and you'll notice now that I have two equations with just two variables. I will now call those equations A and equation B. And once again, I'm going to do substitution, so I'm going to solve for one of the variables. So I solve for a, and I got that a is 4 plus 2c. And I'm going to substitute that into equation b, distribute, collect, and simplify, and we get that c equals -1. And then if I plug that value for c back into equation a and simplify, we get that a equals 2. And now we have these three values. A is 2, B is -1, and C is -1. So I'm pretty sure this is the answer, but I'm not positive until I check equation 1 and you plug those values in, and it does work. And you have to check equation 2, and it works for both of them. We don't need to check equation 3 because equation 3 is one of the answers. And so we are done. Solving a system with 3 or more variables by elimination. Here's a system. First of all, you choose which variable to eliminate. We could eliminate the variable x, and to do that, the two pairs, we would take 3 times equation 1 and add it to 2, and that would get the coefficients of equation 1 and 2 to be opposites. And similarly with equations 1 and 3, if we just add them together, because if you look at them right now, they're already opposites. One's a positive x and one's a negative x. But I didn't have to eliminate x. Remember, you make a choice. You could have decided to eliminate the y. And if you were going to eliminate the y, this is what I would do. I would do -2 times equation 1 plus equation 2, and that would give me opposite y values. And then adding equation 1 and equation 3 is going to get rid of the y value. So those are the pairs that I would use. I'm going to eliminate the x. So I'm going to do 3 times equation 1 plus 2, and there it is. Collect and simplify, and that would become my equation A. It has 2 variables. I went from 3 variables to 2 variables. The other pair is 1 plus 3, equation 1 plus equation 3. And there they are. Collect, and I go, oh, it actually just solved for one of the variables. Although that is equation B, it was nice because I got that z equals 2. So I can plug that into equation A, and by doing that and collecting and simplifying, I get that y equals 3. Now if I use both the answer from when I have equation B here and when I substitute it in for equation A, I can plug both of those into the very first equation, equation 1, that we had up here, plug it in, collect and simplify, and we get that x equals 1. So I'm pretty sure that the answer is 1, 3, 2, meaning x is 1, y is 3, and z is 2. But you've got to check both of the other equations. I already have equation 1 because I used equation 1 to solve for the x. So I'm only need to check equations 2 and equation 3, and it does work for both of those. So indeed the answer is the triplet, the ordered triplet, 1, 3, 2.